Hello, I'm Jude Jason Jacob, URK 19 CS1129. Today we are going to see the operating system lab in this the experiment number 5, that is classic problems of synchronization using semorphs. Then this is a question. This is three questions. We need to first we need to read and write do the program, that is read and write using C++ or Python. Then next problem is to we need to give producer consumer problem, that is by using sum-offs. Then the last question is we need to do with dinner. The concept is dinner philosophers. We need to use C++ or Python. Now we can see how to do this problem. This is a structure of producer process. It is the structure of the program which we need to do, and this is the structure of consumer process. It is the body of the structure of consumer process. Now we can see the program. This is a code. First we need to initialize the mutex in global variable mutex empty full. These are the variables which is added to the global variable. Then we are defining wait find function. Then we are using the if statement. If find is equal to empty, if the condition true, it will do the process of global empty, and it will produce the value empty minus is equal to 1, that is empty minus 1 is equal to empty. Then it will do this process. Otherwise, if the if statement is false, it will enter into the elif statement. Elif statement consists of find is equal to mutex. If this if will find whether the given user given thing is equal to empty, it will check the condition. Otherwise it will enter into the elif, and it will check whether the user entered values equal to mutex. It will check according to that. If this condition false, it will directly goes into the elif statement. Otherwise it will execute mutex minus equal to 1, that is mutex minus 1 is equal to mutex. Then if this condition also false, it will enter into the elif. Next elif that will that have the full. It will check the user given value is equal to full. If it's true, it will print. It will get the value globally full. Then it will do the process full is equal to full minus 1. Then we are defining the signal function. In this we are doing the process. In this we are giving we are incrementing, that is empty plus is equal to 1, that is empty is equal to empty plus 1. We are adding 1 with the thing, same like that we done before. We are here we are subtracting, here we are adding, that's all. It will check the condition before we done, like that. Then we are giving n is equal to int input. This is the input we need to get from the user, and we need to check. We are giving mutex as 1, empty as n, full as 0. It will check the condition. First we need to print the user to find which is the process. First we need to give produce, second consume, then exit. If the user give the choice as 1, it will show the produce option. Otherwise it will show consume. Otherwise if the user give 3 means, it will directly exit. Now we can see how the choice will work. The choice will if we are using if statement, it will check the condition. If the given choice is equal to 1, it will do this process. Otherwise directly it enter into the else part, and it will print buffer is full. If this condition fails means, it will directly enter into the elif, and it will check the choices too. If this choice also false, it will directly enter into else part, and it will print buffer is full. Then the third condition is 3. it will directly break if the user given values above, greater, or not equal to the given values. It will directly show invalid input. Now we can see the output for this thing. This output, um, first I gave 5, it will show nothing. Then the choices, buffer size is 5, I give buffer size is 5. Then the choice is 1, it will show the um, produce, that is 20 produce. Then the choice is 1 and I give the value produce as 30. Then again it asks for the choice, I give 2, it will consume the thing and it will show the consumed value is 30. The last produce value it will take as consumed, and then it again asks for the choice. If I give the choice, it will show the consumers 25. When you give 3, it will directly exit. Now we can see the next question. This is the second question. And we are using from random. We are importing shuffle and choice. We are using the same thing, that is mutex empty full and including or index and windex. And then we are using count variable right. These are the things we are globally assigned. Then we are defining the wait function. um Same we done before. Here also same thing we are doing. Here we are doing is same the thing we done last program. And here we are giving right, empty mutex full, including one thing, that is right. We are checking the right. Then we are defining signal function. In this same like that, we are incrementing, we are adding the empty or mutex or full with 1. That's all. These are the thing. Here the here the right is not available. That's all. Now we are using the defining the readers function. In this we are counting, read count is equal to 0. It will check the condition. It will do read count is equal to read count plus 1. It will check, here we are using if statement. If read count is equal to 1, it will execute this part. The part was um, wait right and signal mutex. These are the things we are included. Here it will print the readers count. It will show the readers count. Then the next statement consists of, it will check read count is equal to 0. If this true, it will give this thing, that is signal of right and signal of mutex. This will be provided. Then we are defining the writers function. We are giving wait function. In this we are assigning count and index as global variable. Then we are counting, we are using the count variable. Count into is equal to 2 means count is equal to count into 2. It will be multiplied, count will be multiplied by 2. Then it will store in the count. Then it will print the right value and modified count value. Everything it will be um, give in the output screen. Then Windex plus is equal to 1 means Windex is equal to Windex plus 1. It will be incremented, it will be added in Windex will be added with 1. Then the signal write function we are using. In this we are checking mutex is equal to write is equal to count is equal to or index is equal to these all are equal to 1. It will do this process. The process is read count is equal to 0, functions is equal to read write. This is the main process, read and write. The range is to 15. This is the range choice we are giving. Now we can see the output for this thing. This is the output. First I gave write as 1. It will modify count to 2. And then read one give read can't ask two. Then this is the output for this program. Now we can see the next code for this program. This is the third code. Here we are getting random, that is from random, inputting choice. We are assigning a as global variable and defining the wait process num. Then same we done before, slightly it will be changing, not so much. It will we are defining signal and process num and everything it will be and assigning, and we are using while I is equal to 0 means it will do this process. If I is equal to 0, it will do this process numbers is equal to 0 1 2 3 4. It will be checking, and it copy 1 will be process numbers, and copy 2 will be process numbers. In this, we need to show the user to do the one of the things in this this is three things. The first thing is to one can eat at a time, otherwise two can eat at a time, otherwise exit. This is the choice we need to give to the user, and we need to get the input from the user. So we are getting input for this thing and checking the condition. If p is equal to 1, it will do this condition, otherwise it will do it will enter into the else part. If the process is done, um, it will check the if statement. If length of process num is equal to 0, it will there is nothing, the value will be 0 means it will directly break. Otherwise the value is 2 or 1, it will do this process. Then we are printing, then we are using the another one while loop. In this while loop it will check the condition, that is waiting time, eat time, everything it will be calculated here, and it will be printed. Then if the while loop or if statement fails, it will enter into the lf part, and it will check if the p is equal to 3, it will break. Otherwise there is no choices, not in the range, it will directly print invalid choice. Now we can see the output for this code. This is a code. First it gave one can eat at a time, two can eat at a time, exit. First I gave one, it will ask for the thing. P2 is granted to eat, P3 is waiting, P1 is waiting. It will show like this. Then P1 is granted to eat. Next it will be getting, and P2 will be next two will be waiting. Then P0 is granted, and next two will be eating. Um, like this. Then P0 is granted, and P1, P2, P4 is waiting. P3 is granted, then 2 is waiting. 1 will be granted and 2 will be waiting. If I give 2, it will permit 2, and it will show one waiting, one waiting. P4 and P1 are granted, P2, P3, P0 is waiting. This is the program. If I give 3, it will be exited. Thank you. This is the program which we done.